Hey everyone, this is Cullen Landrum, and today Fernando and I are going to walk through a little bit of a discussion about Levenshtein, and I make fun of the name if you're a Mel Brooks fan and you remember Young Frankenstein. So Levenshtein is actually how you pronounce it, but I say Levenshtein just to make it funny. But really talking about how we can help with duplicates, right? Finding duplicate matches in Identity Security Cloud, how we can handle those. So, as I said, Cullen Landrum, Advisory Solutions Consultant here at SailPoint. I've been here for going on 8 years, but in this space. Fernando, if you want to say hi.
Hi, Fernando de los Rios here, also a colleague of Colin, but this time from EMEA.
Okay. Let's go through this a little bit of agenda, background, who is Levenshtein, what's his model, why is this important, get into a demo, and then Fernando's going to walk through the dissection of the solution, how he came up with this, and it really is Fernando's solution. But I thought this was interesting when we talked about this. Fernando said he had put in this model created by Vladimir Levenshtein, and basically what it's all about is comparing strings and saying, hey, I've got these two strings, how close are they? How close is it? How many substitutions do I need to make in the string to make these two things look like each other, right? So that's what this is all about, and it's this distance algorithm, right? So if we look at the algorithm, this is really a pictorial graph representation of it. You know, you can go through this from a math perspective and figure out what all it's doing. But the idea is how many insertions, single character edits, insertions, deletions, substitutions are required to change one word into another, right? So how much of a variation is one word to another? Because when we start thinking about doing matching on things like names, which is very prevalent in the space I work in a lot, is higher education. So doing name matching, right? We do that quite often, but those names, they have to be exact matches when we're just doing string compare. So with using this, we can have, a little bit different approach to this. So on here, you think about some of the struggles that customers may have, right? I talk about higher education matching, we're matching names, right? So we're saying, hey, does first name match first name, last name match last name, email address, stuff like that. So those cases where you have multiple authoritative sources, but you don't have a common identifier, right? I don't have a common email address, I don't have a common employee number, I don't have a UIN, if you will, nothing that's common between those different authoritative sources. So how do we handle that? Attempt to match on things like name, address, date of birth, other attributes that they're bringing in, different typos, right? We see that a lot, or you'll see on the next slide some use cases that we got from a university of ours. Using this model, we can look for those string compares. We can find, and you'll see in the demo as we get to that in a minute, things like Benjamin and Benny and Ben, right? Those could be all the names, a first name, or like myself, I go by Cullen, but my first name is James. A little unknown fact about me, but I could be James in one, I could be Jim in another, I could be Cullen in one, right? So it's still me, right? So we've got all these different ways that a person could come in, and how do we know, that they are a match or they're not, right? So that's what this is all about, is giving that potential match. And these are some of the other options that we talk about. I talk about using this Levenshtein model. There's other ways that we could do this, and Fernando will get into that a little bit more as we go through this. But it's basically when we start thinking about, hey, could we use AI? Could we use a large language model to do this? So these are a couple of use cases that I got from a customer years ago, where they had these comparisons, had these near bio matches, or what they called a near bio match, and others. And it was an interesting little fact, as we're sitting there demoing to this customer, the lady sitting to my left would, all day long during the whole thing, she was on her phone, and it was distracting at first, but then I understood why. Afterwards, I talked to her and understood why. She was going through the entire time and doing these near matches, right? So at this university, And doing these, reviewing them, hey, are these the same person they called up? Now I've got to go in and remove things in Active Directory, change things, move them to a different OU, all kinds of different things that she had to do on the back end when their identity management system didn't catch these kind of things, right? So this is really why it's important to the higher education space and to others, right? I can see a use case where we've got people coming in from, let's say, non-employee risk as an example. So they're coming in from that environment and they become an employee. How do we match them? How do we know that that contractor is the correct person and to match them to the employee record and not create a new one? Or the employee record to the contractor. How do we know that those two should match and make sure that we're all on board and make sure everything works, right? So that's what this is all about, is having those making those matches, understanding where that's all at. So let's get in there and take a look at it. We're all developers geeking out here this week. So this is kind of how it works in a pictorial example, and then I'll get in and show it from a real life example. So we've got Mark Jones here, who's coming in from a student information system example. And we bring him in and we aggregate from a source A. We check for matches, no matches found. This is kind of stepping through this. We map some attributes. We generate a unique ID potentially. We saw some of that earlier this week where there was some, hey, go out to a database and generate a unique ID. Cool, we could do that. We could call a workflow, do all those kind of things as well. And then we assign the identity profile that creates the identity. Sorry, lots of buttons here. Creates a unique ID, goes through all the transforms, roles are assigned, accounts are created, right? So we go through and do that provisioning step, right? We haven't done that yet. So let's say another user comes in from the HR system, Mark Janes, right? It's close. So we look through there, we aggregate from this other source, and we say, hey, there is a potential match here. We found something that we think matches. So let's go have somebody review that. So we send off a form, create a form, send that off to a reviewer. They have to go through, review, determine, hey, are these the same people? Are they not the same people? And make that decision. So it allows us to kind of stop that aggregation in the middle, in midstream, and go through and determine, yes, this is the same person. So let's just assign that HR account to the identity, right? Bolster up that identity cube, have the additional accounts in there, and go through and do whatever we need to do from a provisioning perspective, right? Makes sense? So let's get into here. This will be the demo. So our actor today, name I made up, Benjamin Hicks, right? So I went out and made it up. Already got him in the HR system. So we'll go through and aggregate in there, bring that user in, see what happens with him, add a second authoritative source with a different name, right? He's going to go from Benjamin to Benny, I think is what I set up. Aggregate that account, create a form, right? Review the match, merge the user. So that's kind of the whole demo, if you will. So let's jump into here. And over here, we've got, I'm showing, hey, he doesn't exist yet. So let's jump into the connector, into the source here. And we've got the HR source. We're just going to come over here real quick and aggregate that. So he doesn't exist yet. Oh, sorry, he's already, yep, I just need to import that. Sorry. Import the CSV there. He's already in there. So we'll see this number bump up by 1 as we go through there. So it's going to go through and aggregate that user in. We'll take a look at him as he comes into there. All right, we'll see that user. All right, so it bumped up 1. We'll get in here. We can search on him. We can look down into here. We see this uncorrelated account for Benjamin Hicks, right? Remember when I said on that prior page, I said, hey, we're going to bring this user in, and they're going to be basically an uncorrelated account. We don't know what to do with this user, so we brought them in. And then the next step to that is to go over to our other source and say, hey, let's bring, and we call it Identity Fusion. We came up with this name, Fusion. Actually, Matt Giblin came up with it. So he did a little searching, trying to figure out a name to call this. We kept calling it different names, so he finally came up with a name for it. We're going to come into here, and it's that second aggregation, so we'll kick that off. And basically what it's doing right here is going through and looking for that user. Hey, where do we put them into here? Where is this user going to come in from? And looking at I haven't looked at this configuration of this connector or talked about it. It's really it's a loop back connector. So it's looping back into our environment, SaaS connector. We can see it going back into there using ID token, personal access token, and we can see where we're reading from. So I said that HR source, there's also the faculty and the student information source, right? We're going to do, how do we know what attributes to use? Do we want to delete accounts? And Fernando's going to go into more of this kind of stuff where he, when he created this connector, how it all works. But really the things down here, the unique ID scope, is it for the platform? Is it for the source? Are we going to normalize special characters, remove spaces, create the ID based upon this velocity, Apache velocity template, right? So go through here, understand how we're going to do that. When we do find a duplicate configuration, what attributes do we want listed on the form, right? So we want first name, last name, department, email address. That's what we're going to put on the form. Who's going to review this? Right, days to expiration, and then this is where that Levenshtein model gets into play, right? This is where we say we're going to look at first name, we're going to look at last name, we're going to look at email address. We've got EduPerson affiliation here as well. We're not going to look at that, right? There's a little checkbox here that says we're going to use it for the unique identity generation only, so we're not going to use it for the matching logic is what that's saying. So, and then we have a merge configuration that says how are we going to use this. You'll see this later. We're going to concatenate these values. Really cool thing that this can do. Right, so brought that user in. Let's go take a look at them real quick. Let's go over and take a look at our user. Let's get back to there, get out of here. Right, so let's go down. Sorry, just looking at something there. Let's go take a look at our identity. Should be in there. There he is, Benjamin Hicks. Got him as an unmatched, right? We see that EduPerson affiliation show up in there, right? We've got all his information, the accounts that he may have, right? He's got that HR source, so we know he came in from HR source as Benjamin Hicks, right? So that's the first one. Let's go to the second one now, right? So we're going to bring in a different authoritative source, or second source that we're going to bring in here. That's this one here, right? It's a database that we're bringing in, a MySQL database. So let's go ahead and import that data, right? You're going to see a lot of manual aggregations that are happening here. Obviously, in a production world, we're going to have that all timed and scheduled, and all those kind of great things are going to happen, right? But we see we brought in this other person, 10 users there, and go look in here, and we see that uncorrelated account for Benny Hicks. So I should have received, and I did. So you can see we received this email. That's for Boomer. Oh. They're both for Boomer. That's not good. Okay. So we can see this brought in. Maybe it's going to take a few seconds for this to, let me do that again. So we see that we kicked off one for Boomer here. That's a different person that had the same issues, but we can see, it sends me a email, says, hey, go out and check for this user. Is there a match? We can look at this. We could come into here. Oops. Have that, we see the whole match. Hey, we're looking at this user. We think there's a potential match. We're going to say, yep, it looks like there is. We've got this BSI, and we'll switch to that, right? And then we've got all the information that we said, right? Back to that configuration, we said we want to see first name, last name, department, email, and then the score, right? This is the score that we got that shows us how close these names are, right? So we can submit that, right? Goes through, submits. We see the that processing happen. We'll switch over, right? So let me Get out of there. We'll go back to the identity. And we'll change, since that one didn't fire, we'll take a look at that. But we should look at Boomer here and see, hey, he's got some information. He's got different accounts that are going to show up on here, right? So let me kick off that. We've got some of his accounts, some of the events that happen on this user, right? So what's this doing? Going through and calculating where this user's at, what their EduPerson affiliations may be. I'm going to get out of here and refresh that as we go through. And we'll see some things change on this user, right, as we connect into there. I'm going to check back and see if I got, yeah, there we go. So I finally got my Benny Hicks, right? It took a little bit for that to come in. So let's do that again as we've got that guy now and see what, oops, that's not what I wanted to do. I wanted to copy that. Jump over to here. So since I'm already logged in here, you don't have to see me log in again. We can get into there, same form, right? So we see Benny Hicks. We're going to assign him to B Hicks, right? We see Benjamin Hicks information down here. We submit that form. It goes through and does all the things that it needs to do, right? So that's all good. Let's go back here and take a look at this user. Let's switch here. So we switched back over to Benny, right? We're going to take a look at him here in a second. It takes a few seconds for that to process and go through, so we're going to give it a second to do that. Let's take a look. So now we see the faculty current, the staff current, right? So I talked about that concatenation. So if we see multiple values for a user, what do we do with that? And here we determined, hey, we want to concatenate that value. So create a string that has both of those in there. In a higher education use case, then you can use those for role membership, assignments, all that kind of good stuff where we can go through and say, if you're a staff, then you get this value. If you're a faculty, you get these other roles and assignments, all that kind of good stuff. So that's what that's all about. We see the accounts here for that user. We see the HR faculty as Benny Hicks. We see him as Benjamin Hicks from the HR source. All the details about this user, all their information, right? So now, that's what this is all about, is going through and doing those aggregations and saying, hey, everything comes into here. We know what the user is. We know all about them, and we've matched them, right? So we determined they were close enough that we needed somebody to look at it. If it's 100% match, then we're just going to go through. If it's a 0, then we're going to go through. But if it's that closeness factor, using that model to determine how close are these things, then we're going to go through and say, that it's something that needs to be reviewed, right? So let's go take a look. I haven't shown a whole lot about this identity fusion. We talked a little bit about it, but there's some great information in here. There's entitlements that we're assigning to users, right? To say if they're baseline, if they're orphaned, reviewers, what's going on with them. In the configuration, you see the account schema, right? So we're bringing in all the different attributes from the different systems, right? So you'll see multiples in here, because really what that's doing is when we assign these sources, we're looking at those different sources and bringing in all their schema items and saying, hey, what do we need to bring in? What all different values do we need to bring from these three? Bring those into here so we have them all as a part of this schema so we can do things with them, right? So we can manage those. And this is where you see some, I talked a little bit about that. The first found, how are we going to use different attributes that are coming from different places? Where are we assigning? Is it at the source level? Is it the platform, using this velocity template, right? So lots of different configuration options that are available within here, right? So you can go through, configure those, add more attributes if you need those in there. These are things that are going to be in the form, like I showed you when we went through there. Who's going to have to do the review? You saw it come to me as a reviewer, and I would go through and review that form. This is where we're defining the value. I talked about that customer that did this. Their value was 83. They went through and determined that when they're doing their match, it was a Yarrow Winkler. I didn't talk about that. It was on the slide. But when they did their way of matching and looking at this modeling, they determined that 83 was the right number. If you get it too high, you're not going to get potential matches. You get it too low, you're going to have too many, right? Too many false positives. So they determined that 83 was the right number. We set it at 80 in here just to make sure that we would get users in the merging process. So, and then down here, a great addition that Fernando put in here was that ability to do, like we saw, EduPerson affiliation, having additional attributes that aren't a part of the correlation logic. They're not a part of that logic, but they are available for us to do things with, where we could do like this merge configuration and doing the concatenated values. So that's everything I was going to go through from a demo perspective. I put a bunch of slides in the showing all this in the presentation, just in case things didn't go well. And the access history, that's why I put that in there, so I would see things. So let's talk about that a little bit. It does generate all the access history like you would expect, right? We're going to go through there. Oops. We've got the access history in here. So we've got, if I do my user, Hicks, and bring him up here, we're going to see all the information that happened with this, right? So we did this manual user, we brought them in, we see the change on EduPerson affiliation, we changed department, maybe we changed email address, right? So we see all the things that happened to this user within the access history, right? So all that information is in there, all that audit information. What did we do with this user as he went through the life cycle? We also saw, I didn't show this, I need to go back and show it, with Benny here. There were some awesome things that were put into here. We're not sure. Oh. Where did it go? Oh, it's in here. So the identity fusion, if we look in here, right, we see some attributes about this user on this identity fusion attribute, where we see the history. Hey, no match found, assignment approved by me, right? So we knew that user came in. There's a couple of accounts on them, right? This is where we see the EduPerson affiliation information, right? So all those details that we have about this user, all the history, all the accounts information is all within their identity cube, within this account that's on the identity fusion account, right? So showing all that, having all those details about what happened with this user was definitely something that we wanted to have be a part of this. Cool. And over to you, Fernando.
Thank you very much, Colin.
You bet.
Okay. So now that we've seen the connector in action, let me explain how it works internally. Before I do, I'd like to quickly explain why I created it. There are two main reasons, and both revolve around the concept of uniqueness. They are identity identifiers and the duplication. First one, identity identifiers, is a common request from customers. Some organizations can consistently generate them from their own systems. However, some others expect their identity security platform to provide them instead. Generating these identifiers is generally a process of applying a template and some transformation to remove special characters and adding some counter for the duplication. This is one of the things this connector does, but you need to understand why we're using this connector for something so simple. The answer is ISC asynchronously creates identities in multiple threads, and race conditions occur when checking for uniqueness. While some cloud rules attempt to solve this issue, this connector is more flexible and adds more value in my opinion. In order to avoid these concurrency issues, the processing occurs on the account aggregation only. This allows to process both existing and new accounts in control context without having to worry about race conditions. Second one, the duplication, Colin already mentioned it. It's a typical challenge when dealing with multiple authoritative sources with data discrepancies. Identity attribute-based correlation requires exact data from multiple sources, and it fails on the slightest difference. With this connector, we can still rely on our typical correlation configuration and complement it with manual reviews when new accounts are fairly similar to existing identities, all based on connector configuration. You've seen how this works already. Both features combined improve the identity onboarding experience a lot when multiple sources contribute to identities and ISC must act as the source of truth. Okay, now that we took that out of the way, let's see how the process works. As I mentioned already, and as you can see on screen, the processing happens on account aggregation. This process basically processes existing reviews, existing processed accounts, and new unprocessed accounts. As everything happens aggregation after aggregation, we start by checking if there are any form instances completed, which are our manual reviews. If there's any, this will create a new account on this source if the response was, this is a new identity. If an existing identity was chosen from the form, the new account will be linked to that identity's proxy account. So that account is correlated to the identity and contributes to the attributes of the proxy account. We probably haven't introduced the concept of proxy account yet, but it's basically the result of combining all source accounts linked to one identity into a representing account. That account merges attribute data and keeps a log of changes to the account, as Colin showed. After form instances, we process correlated accounts. Correlated accounts are those which are already associated to an existing identity. Now it's time for uncorrelated accounts. We need to differentiate between the first iteration and subsequent ones. This is so because in order to deduplicate, we need to compare to an existing baseline. It is recommended to use a clean initial source that we know it does not contain duplicates. This can be an auxiliary delimited text file that can be removed after, for instance. Once we have a baseline, we can remove that initial source and add as many other sources as we want to process. It's often preferred to add them one by one, so previous results can be used when processing new accounts. The processing of uncorrelated accounts consists of performing a similarity check based on the configured parameters. If the specified account's attributes are identical to an existing identity, the account is automatically correlated to it. If the check yields similar identities, a new form is created and form instances are sent to the recipients for review. If no identical or similar matches are detected, a new account is simply created as it has all the looks of a new identity. Finally, we need to do some maintenance. If there are any existing forms with missing instances, we create them and emails are sent to the recipients. Also, since we've finished processing all accounts, we can now process reviewers, who also have a dedicated account of their own. These accounts are processed similarly to correlated accounts with the addition of pending review information, so an admin can check pending reviews by inspecting reviewers' accounts. And that's overall how the whole process works. Now we can dissect three aspects of the connector that are technically challenging or interesting. First one is finding similar identities. As we said before, Levenshtein distance is not the only option or the best here. It was the lowest hanging fruit when I started building the connector. Whatever method we may want to use, it needs to support setting a group of account attributes to compare and some configurable threshold. In this case, the function goes from 0 to 100, being 0 totally different and 100 exactly the same. If you decide to replace it, you need to consider this and replace the dedicated function with your new logic. I try to make it in a way this check can replace by only changing this dedicated function, but you may need to introduce other changes in some circumstances. Another important detail to consider when making these comparisons is that we are comparing new accounts with existing identities. Each source has their own schema and is likely different to the identity schema. It's for that reason the connector includes an attribute mapping configuration section that allows to select one identity attribute to associate with multiple account attributes. For example, imagine you have two account sources that provide the first name attribute. One uses the attribute given name for that value, and the other uses first name in 2 words. You need to create a mapping for first name, 1 word, and those 2 account attribute names so we can consistently compare the attribute, whatever it is the source it comes from. We need to use this configuration to normalize account data before we can run any similarity check. Now let's talk about processing forms. Probably the most challenging aspect of this connector. When I first started working on the connector, I thought it would be possible to have a single forms template. I wanted to feed different data to it for each identity review. Then I found out it's not possible in this context. The form dynamically shows identity details based on the drop-down menu. This requires dedicated form condition blocks for each similar identity that was found. We cannot dynamically create condition blocks based on input. Basically, we cannot create more or less elements depending on the identities the form must include. Let me show you what I mean. Here, we go to global forms, and we have a series of pending reviews. We can start with this one. Let me show it to you in Builder. Okay, you see that there's only one identity. Okay, only one identity existing in the drop-down menu, and then that identity has a form. Okay, has an information block dedicated to it. If we check the form conditions, we can also find that there's a series of conditions related to that block I showed you before. Okay, so what I mean is, if we go to a different form, like this one, Elliot. Go to Elliot, edit in Builder, okay, and we check the list. We can see there are two identities. Okay, so the difference is we have 2 other blocks, and on top of that we have double amount of conditions here. So these conditions and the other block cannot be automatically generated by the input we pass on to these forms. Okay, so it's a new dedicated form each time you have to review an identity. Okay, let's move on. Ultimately, there's also an important detail I'd like to talk about. It is the fact that when creating a form instance programmatically, IEC doesn't automatically send an informative email to the recipient. This could be misleading when you are used to creating form instances from workflows. On workflows, an automated email is sent when you use the create form action. However, this is the behavior of the action, not the forms API. When creating forms from the API, the recipient doesn't get notified. You need to manually send an email. In my opinion, the easiest way to achieve this is by adding a simple email sender workflow to your connector. The idea is ensuring the workflow is present on the system, and when an email must be sent, we can just use the workflows test API with the proper input. The workflow runs and the email is sent. For email composition, I reckon the most convenient thing is using a Markdown library that simplifies creating the HTML. Now let me show you what I mean by this. Go to workflows, okay, and the connector automatically ensures and creates a dedicated email sender workflow. If we inspect it, we can see it's very, very basic. It's just an external trigger that we actually don't use, a send email action, and the end of it. If we inspect the send email action, we can see that we take recipients, subject, and body from the payload, okay, from the external trigger payload. but we're actually not going to invoke it through HTML, through HTTP or anything like that. We're just going to use the test API for that, and it works. I mean, it's a simple way to send your own emails for this reason, this particular reason, or for whatever reasons you have. Okay, so see what's going on. There are some issues here.
Very nice.
Give me a quick second.
Do you need the slideshow adjusted?
Slideshow, yeah.
Yeah, it's a lessons learned. What do you look for?
Your notes.
Yeah, they were blurred. Okay, ready. Well, I hope you're familiar with enough with this connector for now. I encourage you to try it out and engage in the forums if you have questions and suggestions. Now, I'd like to share with you a few lessons I've learned during the process. They were very helpful to me, and I hope they will be helpful to you too. First game changer for me, specifically when building these kind of loopback connectors that use ISC API, was switching from Axios HTTP calls to the new SailPoint TypeScript SDK. It can first feel a little bit daunting, but it only lasts a few moments. Trust me. It is true that it's very easy to build your own Axios HTTP calls, but most API call functions are copy-paste of the previous ones with some input changes. Pagination can often be reused when you implement it once and the documentation is good. However, API responses are not typed, and you need to know in advance the kind of data to expect. This is what the SDK changes completely. You just need to import the right API and find the function for the endpoint you want to call. Also, you get typed responses. They considerably improve the experience when building data pipelines and development in general. Autocomplete just works, and you rarely need to check API documentation as it's embedded in the IDE. If you haven't tried it yet, I deeply encourage you to. It's a serious improvement. Let me show you what I mean. Okay, this is a different connector. Okay, a connector I started working with pure Axios code when the SDK was not available yet. And you can see it's typical connector where you configure Axios with retry conditions, etc. You also needed to implement your own authentication method. And if we scroll down a little bit, we can see that most calls you make, most functions are basically the same. Basically, pointing to the right URL to select the endpoint, construct your request, okay. And if you need to add some pagination, you add the pagination to the end of it, and that's all you need. Not too complicated, absolutely not. But the problem with this is that if you check that the function description, the response is of any type, so it's not typed. We don't know what we're going to get from each one of these functions. So this is the equivalent, okay, of the previous version of the client, but this time implemented with the SDK. You can see that first of all, you can still tweak, you can still configure those Axios options as before. Okay, very handy to manage delays and stuff like that. Then, apart from that, you don't have to deal with the authentication because that's already in the SDK. And if you look at the type of functions that I have here, those are very simple. Okay, very similar to each other, and basically it's finding the right API. Here you instantiate it, and then you can call any method from the API. When you do, I mean, you can even use the the paginator class, and the pagination will be taken care of for you. Very simple, but the best thing of this is is having type responses. Okay, you can see that here we know that we're gonna send a promise of work of a list of work group DTO beta, and you can even go to the type definition, and IntelliGence also picks it up, and you know exactly how this output, how these objects look like. Okay, so really handy. Now let's go back to the slides. Now let's talk about something interesting that is not too obvious. Working with multiple entitlements. Default account and entitlement schemas are defined in connector-spec.json file. This is the configuration the source gets by default the first time it's created. You can define one account schema and multiple entitlement schemas. If you look at the account schemas, the account schema attributes, you will notice the group attribute option. This only allows you to define a single attribute entitlement attribute. It's best you don't use this option, and instead you tag your entitlement attributes with the schema object type option. That way, you can use multiple entitlement types. You can do exactly the same when implementing the account schema discovery operation, if you will. When working with multiple entitlement types, you must take into account their type on each operation. Aggregation operations include the type of entitlement to return. You must read that and send the right data back. Account provisioning operations don't include the entitlement per se, but remember the account attribute in question defines the entitlement type based on the schema you define. Okay? Let me show you what I mean. Here we have the identity fusion, source code, connector spec.json, and at the bottom of it, we have defined the account schema. It's a single declaration, but you also have entitlement schemas. You can create as many as you want, since this is a list. Okay, and the way the original way was to define a group attribute and identify which account attribute was going to be your entitlement. Okay, but you can basically do without this, and it's best if you have one or you have multiple entitlement, multiple attributes that are entitlements. You can mark them with the right schema type. Okay, in this case, it's status. You have it here down. You have it down here, and then on top of that, you configure it to whatever you need, and it also needs to go in the default type string. Okay, that's the only thing you need to do. So that way you can define multiple entitlement schemas, and you can reference them easily from the account schema. If you are discovering, you are enabling an account schema discovery, okay, from your source, you also need to implement this. Okay, so back to the slides. Now let's dig deeper into schema management. We talked about how connector-spec.json defines schema defaults on source creation. After the source is created, when schema changes on any side, source or connector runtime, it's not transmitted by default. However, there are a way to bidirectionally communicate schema changes between source and runtime. Let's start with the source. As I mentioned before, the source can dynamically discover the schema from the connector. We need to implement std account discover schema operation for that to be possible. However, this only goes one way. This means that it's the connector that sets the account schema, and the schema change on the source would likely break account operations. In order for the source to provide a custom schema to the connector runtime, we need to enable a particular option in the source. This can be automatically done by adding the appropriate option in the connector-spec.json file. From the connector perspective, implementing the account discovery operation is not enough. When working with custom schemas, the source is supposed to send the current account schema for each account operation in the input object. The schema should be considered when building your responses, or like in the previous situation, it will likely break account operations. Let me show you. Here, first thing you need to do in connect-to-spec.json, okay, is declare that your connector supports discovery schema. Okay, you declare it here. The source knows that and that automatic discovery is supported. Okay, but you also need to implement it, and you implement it here. Okay, just as any other operation. STD account discovery schema is declared here. This is my particular source. But basically, you saw the account schema before. You need to output the same kind of object. Okay, but this time you can dynamically generate it. Maybe we are doing it based on the sources that we read from, but you can just create an account schema depending on the configuration options of the source itself. Okay, let's go back to the slides. Okay, this is something that has been bothering me for a long time, but I finally realized that there was a way to do it. I'm talking about identifying the ISC source that is actually calling the current runtime. When working with loopback connectors, this could be required because you must have a way to differentiate multiple sources of the same connector. In order to identify the source, you just need to list all sources and find the one that matches config.sp connector instance ID value. In this particular connector, it was a must since we needed to read back from previously aggregated accounts. Okay, so let me show you real quick. Here, yeah, context helper. This is what I do when I start my operations. So first of all, I take the ID from the config object, sp connector instance ID. Then I fetch all the sources, and I cross-reference this to find the source that is invoking the code. Okay, so that way you have all the information you need from the source that is actually calling your runtime. That's all. And now, finally, as a wrap-up, a final trick from the back. This one helps with dealing with long operations that may time out. The easiest solution I found, considering the synchronous-like syntax I use when writing my connectors, is opening potentially long operations with a set interval block that periodically sends keep alives using the res object. When you do this runs in the background and you can start processing the operation. Before you finish the operation, you must clear the interval block you created before. As simple as that. You can safely assume your code won't time out as it's constantly sending a signal to let ISC know it's still running. Okay, let's have a look at this. And this is what I mean. Go to account aggregation, okay, std account list. See, one of the first things I do is I declare my interval. I declare my interval, and within the interval block, it's just a keep alive, okay? And the keep alive needs to be sent, but how often? So I would recommend you to do it in intervals lower than 3 minutes, okay? Because it's supposed to after 3 minutes without communication, it's supposed to time out, okay? So you configure this how you will, and basically you keep on processing your accounts until the operation finishes. And before the operation finishes, you clear the interval. So you are safe. You can safely assume that it's not going to time out, no matter how long it takes your code to run. So that would be all. Okay, we are running out of slides. Thank you very much. I hope it was helpful to you. And until next time.
Yeah, and just a couple of things to finish up. Some of the future. Well, you put this all in Colab, so it's all up there, and everybody can access that. And I see, the future of this, where this goes. There's some things that Fernando and I and Matt Giblin, I have to give credit to him. He's been driving this as well. We'll make fun of him real quick. He's over in Italy on vacation right now, so we'll let him slide. But where we're going with this, there's some changes that we want to make this a little bit different, add into there. But I see this, it's out there, it's in the community, it's something that our partners, our customers can take and use and say, hey, we want to, take a look at this, use this, and figure out, maybe they want to use a different model. Their numbers are different. They want to do a different way. That's what Fernando was talking about. If you want to change out the Levenshtein model and you want to make it be something else, then great. Change that out. What's that?
Levenshtein Plus.
Levenshtein, yeah, we heard about Levenshtein Plus. Or while we were here, one of our cohorts was saying that they use a different model, but it's still Levenshtein. It's just a different model. But doing those kind of things, that's where I see the future of this going, is having our partners that focus in on higher education. I work mostly with them, but in other areas as well, where you have any kind of multiple authoritative sources, right? Anytime you have multiple authoritative sources and don't have a common value that you can correlate on, right? If your correlation doesn't work all the time, and correlation still happens, right? Don't get me wrong, that still happens, that still goes on. So you can still have those correlation rules, all that kind of good stuff is still involved here. It's just this takes it to the next level, and so it solves a problem that we've always had in the identity security space, identity security cloud space with higher education. So I appreciate it. Thanks, Fernando, for all the hard work you put in on this.
You're welcome.
It was awesome. You did a great job on this. So
Thank you.
yeah. All right. Thanks, everybody.